Hi class, we are going to talk about how to delete all the nodes in a linked list. So before we go into doing the cleanup for our linked list that we've created, I want to talk about what's coming up next in the videos that's going to that you're going to watch, because just want to give you an overview to make sure that you know that I am right now going through each function by function with you. There's a reason, being that there are different new concepts coming up in each of the implementation. But also at the same time, I want to make you feel comfortable with pointers, because it's such a concept that people seem to struggle. So I want to go through it slowly with you so that you feel comfortable, and maybe you can get that 60-point bonus homework done. It's not an easy one, I would say. The code actually is not that complicated. It's less than 20 lines of code, maybe. But to do it well, you have to be very clear-minded, very in the present, to, I think, be able to work out how that function will work. To anyways, you will look at the homework, or I will actually talk about that later on in one of these videos. So coming up is delete nodes. Later on there will be print, search, insert, and remove. One thing that I want to mention is that maybe to master this material, besides using visual aids to help you to understand, I think even throughout the class, one thing that helped me to learn programming languages is to type the code as I'm watching the video or afterwards, because it's one thing to watch other people doing it, it's another thing to do it yourself. When I type it, I will start to have questions. Why am I doing this way? When I'm watching video, I might not have those questions. Asking questions is always good for learning, and so I hope that may be helpful to you. So when designing this kind of functions for linked lists, what do we want to watch out for? First of all is boundary cases. We always want to see if the function will work in the when it's the head of when in different situations, but there's the head of the linked list, there's the middle part of the linked list, there's the tail part of the linked list. Would they actually behave differently in different parts, right? And what if we start with an empty list, or when we end as an empty list, what will happen? Would those end cases work? So those are boundary cases that we want to watch out for, and in different functions we watch out for different cases. Not that we have to think about all cases in all times, because some are obvious that is not relevant. Another thing to pay attention to is pointers. We are now working with pointers. It doesn't behave so much like other data types, and so sometimes we thought that, hey, something wouldn't change if we do certain things, if we didn't directly change the value of something, but it might happen if you're not careful. So that's one thing to notice. Another thing is that assignment operator doesn't work the same anymore when pointers are involved. For example, if you have two structs and you try to say this node is equal to that node, it actually doesn't copy, like make an exact copy of the node, because the pointer is pointing to still the same value, and so you are basically just having two pointers pointing to the same record, or same node, if you can imagine it. And other thing to think about is before I move on in that concept, think about why when we designed any class that has dynamic array or pointers, we have to create this big three: the copy constructor, the the destructor, and then the assignment operator. Why do we have to do that? It's basically this reason, because they don't function the same. And then be careful with the head pointer. So we cannot, we cannot make the head pointer constant, because sometimes head pointer has to change value. For example, when we delete all the nodes, right, at the end, the head node will become not null pointer. It should point to a null pointer at the end. And so we have to allow the head pointer to change. However, when we change the head pointer, we have to be very careful. Why? Because if we lost the head pointer, we are going to lose the whole linked list. And so all the memories are going to be lost, being allocated, but not being used in the program. Now, let's talk about the function that we are going to write in this video. It's called delete all nodes. We are going to remove all nodes and basically act just like a destructor. So if we write a class for nodes, if we write a class for linked list, then this code will go into that destructor. One thing to think about is if the head will keep changing, should we pass the pointer as reference or by value? And if we don't pass it by value, the head will be still pointing to something that has been deleted. So after we delete all nodes, I would think that, or you probably would know, head should be pointing to a null pointer at the end, right? So that it's not dangling. So that's why we want head to be passed by reference, but that's not the only reason. However, if we think about that way, it's easier to decide basically. So where we added 3 nodes into our linked list, 10, 9, 8. Not that this is the only case the function needs to work, but this is a good example to think about how we can how we want the function to work. So we have now 8, 9, 10 in our linked list. So what do we want to be? We want to have head point to a null pointer. So and all the nodes are delocated. So the mechanism, I'm going to do it like last time. So how do we want our function to work? We create a discard pointer which point to the first node, basically the same node that head is pointing to. We will change the head to point to the next node. So let's make sure this point here, and then so we are going to point to the next node, but this node is not, doesn't disappear. It's still there. It's being pointed by discard. That's why discard is important. So once head is pointed to the next node, then we can, through discard, delete this node, right? We can delete discard. So this disappear, and of course this disappear too. And so then we deleted one node. Next thing, we will do the same thing. We have discard point to where head is pointing to again. And then we have head point to the next node, which is this node right now. And then we say delete discard again. And so this node will disappear. We will repeat the same. So let's do this again, because we want to know if it works when it's the end node, right? The last node. So we will say discard equals to head, so it points to the same node that head is pointing to. We try to point to where this node is pointing to, which is now null pointer. And then we say delete discard again, and so this will disappear, I guess, because it's in a group. But anyways, you know the idea now. So to recap the plan, what we were doing, we create a new node pointer that's called discard. We set discard equals to head, and then head will equals to where the discard arrow next is pointing to, and then we delete discard. I know it's a little bit hard to think this way, so but bear with me, because I can't be doing that and this at the same time. But when you design a function, that's basically what is best for you to go through, is to try it out a few times using paper and pencil if you want to. That's what I do, and then I will go through it a few times and then solidify my plan, and then I will write down in English, and then I will go and write the program. That's how I deal with, especially in pointers and some more complicated functions. So sometimes I can do it in my head pretty well, but in pointers case, I will tell you I can't. So if you can, I congratulate you. So so after I set head equals to the basically pointing to the next node, I do a delete of this discard. After it's deleted, I repeat basically the same like you saw. And when does it end? It ends when we set head equals to NodePointer. That's when we end. So just want to show you, this is actually really what I do when I have to write a function or program that is more complicated. I actually will write I would actually say this is the mechanism, because if the function doesn't work after I implement it, I can check the steps and see where the problem came from. And that's why I would say I normally don't debug as long. My one tip is to write down your mechanism. The other one is when you are stuck, go for a walk or go do something else. That's what I found work best for me when I get away from the problem. Like for example, if I spend like an hour or half hour trying to debug, I couldn't figure it out, leave it alone, come back like immediately, you might find the solution. Anyways, so this is the plan in code. We set had so it's a while loop. Well, first step, we were going to create this discard pointer that points to where it's pointing to, and then while discard does not equal to NodePointer, we will say head will point to the basically now they are pointing to the same place, right? The same node. And so I would say, okay, now head points to the next node, and then I can discard this node. That's why the name of the pointer is called discard, so that we know that's the purpose of the pointer, is to point to the node that we want to delete. So we delete discard, so it disappeared, and then we have discard point to the head again, and repeat until discard is equal to NodePointer. We did consider the boundary case already. Actually, what if we start with an empty list? If it's an empty list, discard equals to head will be equal to NodePointer, so discard will equal to NodePointer, and so this loop will not happen, and so things will be fine. We won't be deleting something that were not there. So to just show you the code works, I let's see, I guess we already go through the code, so I will just show you how the code works. I see, I changed the name. Solution. So this is what we did. First of all, NodePointer head equals to NodePointer. I want to remind you again, this line of code is super important. That head is set to NodePointer. Otherwise, it doesn't know that the linked list actually where it ends, right? So we add 10 and then 9 and then 8. So that's why the linked list is printed out as 8, 9, 10. And I actually put a cout inside just so that before we delete, we would print out the data that this card is pointing to make sure that we are deleting it instead of it's imaginary, because nothing happened. It could be nothing happened and still we would not know it. And so I put a cout statement to basically make sure that yes, the node of 8 is being destroyed, 9 is being destroyed, 10 is being destroyed in that order. So to recap, we talk about what we need to watch out for when we write functions for linked list. And we talked about how to write function to delete all the nodes in a linked list, how to write a plan for implementing functions, and then considering boundary cases. So next, we are going to use iterators to do something in the linked list. I will see you in the next video.